Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, I'm going to review how to factor just in case you've forgotten. You're looking for two numbers that multiply to give you 5 and add to give you 6. So the only two numbers that multiply to give you 5 are 1 and 5, and they do add to give you 6. So you'll have x plus 1 times x plus 5. For the math knowledge question, it tells us f of 2n equals 2 times f of n, and f of 4n equals 4. Which one could be our f function? So we're going to start with this one. If we plug in 4, does the function give us 4? So if we plug in 4 here, we get 2. So that could not be f. This one would work. If we plug in 4, we do get 4. If we plug in 4 here, we get 8. So that one can't work. For this one, if we plug in 4, we get 4. And then on this one, if we plug in 4, 2 times 4 is 8 minus 4. That does give us 4. So now we're going to have to pick some numbers and plug in for our n here. So I'm going to let n equal 1. So if I do f of 2n, that would be just f of 2. So if I plug in here, f of 2 would give me 2 because my n value is 2. If I plug in here, f of 2 gives me 4 because I'm always going to get 4 on this one. And then if I plug in 2 on this one, I'm going to have 2 times 2, which is 4, minus 0, which is 0. Okay, and then I'm going to do 2 times f of 1 because our n value is 1. So on this one, our n is 1. And then we multiply that value by 2. So we get 2. On this one, our n value is 1. And so we get 4. And then we multiply our 4 by 2, which gives us 8. And then on this one, our n value is 1. So 2 times 1 is 2 minus 4 is negative 2. And then we multiply it by 2 to get negative 4. So the only one where this is equal is on this one. So that would have to be your answer. These other two don't give you the same value for f of 2n and 2 times f of n. So that's how you would work through that math knowledge question. So we're going to be looking at lesson 1 and 2 today. The reason we're going to be looking at both of them, they're mainly review from geometry, and so most of it you should have already been dealing with, and we're just going to go through them. It's going to be some formulas and stuff, and if you look in the very back of your book, like all the way to the back cover, there should be some formulas, and so if you ever need them, you can look in your notes or you can look back there to see if you have it. But I don't want to skip them because I do want to review it just a little bit, but we're not going to spend a lot of time going over these because most of it should be review. So points, lines, planes, angles, concept review problems, area, cylinders, prisms, cones, and pyramids, and spheres. All of that is going to be covered today. So you should be able to do most of it after we finish this lesson. So a point is a location. It has no size. A curve is an unbroken connection of points. So all of these are examples of curves. You just put your pencil down and you draw something, and that would give you a curve. A line is a series of points that extends in two opposite directions without end. So it goes this direction and it goes that way. And the notation for line, you do a line over and you pick 2 points on your line. So I could pick BC, or I could pick line AB or CB. You just have to pick 2 points that are on your line. Okay, a line segment is part of a line that has 2 endpoints and all of the points between them. And so for it, the notation, you do a line segment and then you do your 2 endpoints. So AB. If we had C here and I said AC, that segment would be only going from A to C. So you got to be careful that your 2 endpoints are the ones that you were wanting. Because if we wanted the whole thing, we would have to do from A to B. A ray consists of part of a line that has one endpoint, and then it goes all the way forever and ever on one side of the endpoint only. So your notation, you always do this ray symbol. Even if your ray is going this direction, it always looks like this. And then the endpoint, where it starts, is the first letter. And then I could do ray AB, or I could do ray AC. Either one, because you have to pick 2 points. If I did ray BC, that would be the one that starts at B and goes this direction. So that would be different from either of these two. Okay? Collinear means that they are on the same line. Non-collinear means it's not on the same line. If you have a plane, it's a flat surface that has no thickness. So the classroom floor is a plane, the ceiling is a plane, your desk is a plane, it's just flat. It has no thickness. If you have coplanar lines, those are lines that are in the same plane, and they may or may not cross. You could be parallel or they could be intersecting, but if they're coplanar lines, that means that they are in the same plane. Okay, parallel lines. Those are ones that are in the same plane, but they do not intersect, they do not cross. And the notation for that is 2 parallel lines. If you have intersecting lines, those are just 2 lines that are in the same plane that do intersect. And you don't have a notation for intersecting lines. Skew lines are lines that are not in the same plane, which means they never intersect, they never cross. So one of them is in one plane and then the other one is going through it, but they never touch. So in a bigger city, some skew lines would be the interstate that have all the overpasses. They don't cross. One is going above and one's going below. That would be an example of skew lines. But they're never going to intersect. So if it's skew, that means that they are not in the same plane. Okay, now we're going to look at tick marks. You've dealt with tick marks before. They just tell you if your segments or angles are of equal length or equal measure. So these 2 segments are congruent because they have 2 tick marks. These are congruent because they have 3, and then these are congruent because they each have 1 tick mark. And then on angles, you could do 1 tick mark, 2 tick marks, or 3. Sometimes they'll do arc marks like that. So those would be congruent because they both have 2 arc marks. So either one is fine with me. But that just tells you if they are congruent or not. So now we're going to look at angle. It's formed by 2 rays that have a common endpoint. So here's one ray going that way, and then another ray going that way. And together they make that angle. An acute angle is one that measures less than 90 degrees. A right angle measures 90 degrees, and an obtuse angle measures more than 180 but less, more than 90 but less than 180 degrees. So hopefully you're familiar with those 3. A straight angle, you should be familiar with a straight angle. It's formed by 2 rays that go in opposite directions, and it's just 180 degrees. So there's one ray, and there's the other, and together they make a line, a straight angle, that's 180 degrees. And then a reflex angle you may or may not be familiar with. So if this angle here is 30 degrees, the reflex angle is the part that's over here. And so the reflex angle is 330, because together this makes the whole circle. And so 30 plus 330 is 360. So this reflex angle is 330. How can we name this figure here? Well, we could name it angle Q. We could name it angle MQB, or we could name it angle BQM. However, you could not name it angle MBQ, because that would be the angle here. So you make sure that the Q, if you're going to use 3, is in the middle of them. If it had another segment here, and it said something about angle A. If I said angle Q, that's too ambiguous because there's this little angle here at Q and this little angle and the whole big angle. So if there are multiple angles at the vertex, one variable here does not work. Okay, so hopefully all of that's review. Now we're going to look at complementary angles. Those are angles that add up to 90 degrees. So y plus 30 would have to equal 90 degrees because they're complementary. Supplementary means they add up to 180. So x plus 40 would have to equal 180 because it makes a straight line. You also have vertical angles. Those are angles that are opposite of each other. So A and B are vertical angles and C and D are vertical angles. And vertical angles are always congruent. So that means that Z would have to equal 3Z minus 80. Okay. So now we're going to move on to triangles. Equiangular triangles means that all of the angles are equal. That means they all equal 60 degrees. Right triangle has one right angle. An acute triangle, all of the angles measure less than 90 degrees, so they're all acute. Obtuse, they have one angle that is an obtuse angle that measures more than 90 degrees. Hopefully that's all familiar. Looking at equilateral, that means all the sides are the same. If you have an isosceles triangle, that means at least two of the sides are the same. And then scaling means that none of the side lengths are the same. Looking at a transversal. So we dealt with these in geometry. It's a line that cuts or intersects one or more other lines in the same plane. So here are two lines, and there's the transversal because it crosses through two lines. So those are some interior angles because they are between the two parallel lines. The reason I know they're parallel is because of these little angles here. That little angle, that little line right there tells you that they are parallel. And then these are your exterior angles. They're on the outside of your two parallel lines. So hopefully you remember your alternate interior angles. One on one side of the transversal and one on the other. And then they're inside of your parallel lines. They're on the interior. Your alternate exterior angles, one on one side of the transversal and one on the other. And they're on your outside. They're exterior angles. And then you have corresponding angles. Those are angles that are in the same place. They are just shifted down from one parallel line to the next. All of these are congruent angles. So alternate interior angles are congruent, alternate exterior angles are congruent, and corresponding angles are congruent. Your same side interior angles are on the same side of the transversal and they're inside of your parallel lines. And so these are same side interior angles and these are same side interior angles. Your same side interior angles are the ones that are supplementary. So you got to be careful. These are different from the other three pairs. Same side interiors are the ones that are supplementary. Okay, so we're going to go over some area formulas real quick. For a rectangle, area is length times width or base times height, whichever one you want to think. For a triangle, it's 1/2 base times height. For a circle, it is pi r squared. For a sector, the area is the measure of your angle or your arc over 360 times the area of the circle. So hopefully you've dealt with all of those before and those are review. If not, you can write them down. You can pause the video if you need to. So we're going to look at finding the area of the shaded part of the circle. So our area formula for a sector is the measure of the angle over 360 and then times the area of your circle. So pi r squared. So it tells us we want to find the area of the shaded region. So this angle over here is 126. So we need to find the angle over here. So if you subtract 360 minus 126, you're going to get 234. So you're going to do 234 over 360 and then times pi radius squared. And your radius is 2 square roots of 5. So then we're going to simplify that. So if you plug that into your calculator, you're going to have 234 over 360 times pi, and then times, you have to be careful when you plug this into your calculator. You've got to make sure that you square the 2 and the square root of 5. And so if you plug it in correctly, you should get 40.84, and it's in meters. So if you want to put it as a decimal, you can do it like that. Or if you want to leave it not in terms of pi, you want to leave it in terms of pi, you don't plug the pi into your calculator, you'll get 13 pi meters squared. So either one of those is fine with me. Personally, I prefer that one, but if you got this answer, that would be okay. So I'm going to go over how to simplify this real quick. 2 square roots of 5 squared. 2 squared is 4, and the square root of 5 squared is 5. So that gives you 20. So this is 20 pi, and then you multiply it by 234 over 360. And so that's how you can get your answer. Okay, so now we're going to look at some concept review problems. So for your concept review problems, you're going to have either A, B, C, or D for your answer. So it's going to look like it's a multiple choice question. A is going to be the answer if A is your larger value. B is your answer if B is the larger value. And then you pick C if A and B are equal. And then if you can't figure it out because they don't give you enough information, you're going to pick D. So they'll look like this. X and Y are real numbers. A is positive and B is negative. We want to compare A plus B and A minus B. So on some of these, you can kind of just pick some numbers and try them out, or you can kind of think about them mathematically. Either way is fine. I like to think about this a little bit more mathematically because then you don't have to try so many numbers. So if A is positive, that means that we're going to have a positive number. A is greater than 0. And then if Y is less than 0, that's going to be a negative number. So we're going to have a positive number plus a negative number. For this next one, X is positive, and then we're going to have minus a negative number. Well, minus a negative turns into plus a positive. And so this one is always going to be bigger because it's going to be 2 positive numbers being added together instead of a positive and a negative. So your answer here would be B. Okay, so that's how that would work. Looking at another one, we know that X is in between 1 and 6, and Y is in between 1 and 6. Is X minus Y bigger or Y minus X? Well, if we pick a number for X and Y, and we subtract them, which one is going to be bigger? So let's pick a number for X. Let's say X is 5 and Y is 3. Well, 5 minus 3 is 2, and 3 minus 5 is negative 2. So then this one would be bigger. But let's say that X is now 3 and Y is now 5. If you subtract, 3 minus 5 gives you negative 2, and then 5 minus 3 is positive 2. So this one is bigger. Well, A can't be bigger on one time, and then B be bigger on the other. So that one would be no solution, or not enough information, which is D. We can't figure out which one is bigger. Okay, so now we're going to look at another one. Given 2 intersecting lines with K, L, M, and N as shown, compare these. So I want y'all to try this one by yourself, and then unpause the video and I'll go over the correct answers. So for this one, K, L, and M are obviously going to be more than 180 degrees. And then we're doing 180 minus N. So 180 minus N is going to be something less than 180 degrees. So A is going to be the largest one here. Okay, so now we're going to look at another one. So again, y'all try these by yourself and then pause the video and I'll go over it after y'all have attempted it. So if we're looking for the area of triangle WXY, that's this triangle here. So to find the area of a triangle, you're going to do the length of the base times the height and then divide by 2. And so the length of the base is XY and the height is from W down here. Okay, and then if you're looking for the area of ZXY, that's this triangle here. And so the base is also XY and the height is from Z down to here. So the areas of these are actually congruent. They're the same because they have the same base, and the height is the same because the height is the distance between these two parallel lines. So your answer here would be C because the areas are the same. Okay? So that's how you can do your concept review problems. So now we're going to move on to lesson 2, and that's where we're going to look at some surface area formulas and some volume formulas. So for a cylinder and a prism, the volume is area of the base times the height. For the lateral surface area, you do the perimeter of the base times the height. And then you would add the bases if you're looking for the total surface area. So if y'all need to pause the video and write those down, you can. So we're going to find the volume, or no, we're going to find the surface area of this cylinder. So our surface area is going to be the lateral surface area plus the 2 bases. So the lateral surface area is perimeter times the height, and then we're going to have our 2 bases. So the perimeter here is going to be 5 plus 6 plus 5, so that's 15. No, that's 16. And then the other part of the perimeter is this part of the circle. And so it's a circumference formula is 2 pi r, but we're only looking for half of it. So we're basically looking for just pi times r. So our radius is 3, and so 3 pi would be the perimeter of the semicircle. So 16 plus 3 pi, and then your height is 10. And then you're going to add the area of the bases. So the area on these, here the area would be 30 because it's a rectangle. 5 times 6 gives you 30. And then we're going to add the area formula of a semicircle. So pi r squared divided by 2. And so that would be your area of your bases. So now we're just going to have to simplify. So we're going to have 160 plus 30 pi. And then 2 times 30 is 60. And then 2 times this that divides by 2, those 2's are going to cancel out. So we're basically going to have 9 pi left. And then if you add your like terms, you'll get 220 plus 39 pi. And your units would be centimeters squared. Or if you wanted to make that a decimal, you could have that answer. So either one of these would be fine with me. I personally usually leave it in pi format, but you don't have to. You can make it a decimal. Okay, so now we're going to look at another one. We want to find the surface area of this right prism. So I'm going to start by finding the area of this front face here. Okay, and there are 2 of them, so I'm going to be multiplying it by 2 whenever I finally get it. So I'm going to break it up into some squares. And so they're all 2 by 2s. So the area here would be 4, 4, 4, 4, and 4. So that's 5. So that's 20 for the front and then 20 for the back. So that would be 40 for the front and the back. And then to find the area of all the side pieces. They are 2 by 6, all of them, and so we just need to figure out how many we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 of them. And they each are a 2 by 6, so that area would be 12. So you should have 40 plus 144, which is 184. And then it doesn't tell you a unit, so units squared. So that would be your surface area for that prism. Now we're going to look at cones and pyramids. The volume formula for cones and pyramids are both 1/3 area of the base times the height. And then the surface area for a cone is going to be pi r squared, because that's the base, and then pi r L, where L is the slant height. Okay, and then for a pyramid, you would do the area of the base, which is whatever figure it is, and then you would do the area of all of your triangles. So there's not really necessarily a set formula that you would use for a pyramid. So we've got a cone here. We want to find the volume. So our volume formula is 1/3 area of the base times the height. So the area of this base, this part is 6, and then this part here is a semicircle. So pi r squared, our r is 1, so 1 squared is still 1, and then divide by 2. And so that's your base, and then the height is 6, because I told you it's 6 meters high. So 1/3 times 6 is 2, and then we have 6 plus pi over 2, which is 12 plus pi, and our units are meters, and we're dealing with volume, so it's cubed. Or if you want to do that in terms of a decimal, you would get 15.14 meters cubed. So either one of these would be fine for your answer. Okay, so now we're going to look at another one. We want to find the surface area of this cone. So for surface area, you're going to do pi r squared plus pi r L. And so your radius here, they tell you is 8, and they tell you the slant height is 10. Now if they gave you not the slant height, if you had to find your slant height and they said the radius was 8 and your height here was 10, not the slant height, then you would use Pythagorean theorem to find the slant height. So make sure you pay attention to whether they give you the slant height or the height of the cone, because sometimes they'll purposely try and trick you up. Okay, so now we're just going to simplify. So this is 64 pi plus 80 pi. So 64 plus 80 is 144 pi, and our units are centimeters, so centimeters squared. Okay, we're going to look at another example. On this one, they tell us the volume is 6 pi, and we want to find the radius. So we're going to start with our volume formula. Our volume is 1/3 area of the base times the height. And they told us the volume equaled 6 pi. They told us it's a circle for the base, so pi r squared is your base. And then the height they told you was 2. So now we just have to solve for r. So I can multiply both sides by 3 to make this 18 pi equals pi r squared times 2. And then if I divide both sides by 2 pi, you'll get 9 equals r squared, and so r equals 3. So that's the radius. So that one you just had to work backwards. Okay, we're going to look at one more for a pyramid now. We want to find the surface area. So for surface area, you want to find the area of the base, and it tells us it's a square base. So the surface area is going to be base plus the lateral surface area. So our base area is going to be 16 because it's a square with side lengths of 4. And then our lateral surface area, we're going to do you can either do 4 triangles, or you could do your perimeter times your height if you wanted, your slant height. But I'm just going to do 4 triangles. So 4 of them, and then 1/2 base times height. So on this triangle, I'm going to use this one right here. The base is the side length of the pyramid, which is 4. And then the height is the slant height here. And they told us the slant height was 5. And again, if they didn't tell you the slant height, they told you the actual height, you would have to use Pythagorean theorem to find that slant height. But they made it a little bit easier for us. So we're going to do 16 plus 4 times 1/2 of 20 is 10. So 16 plus 40 is going to be 56 centimeters squared. Okay, so that would be your answer for that one. Now we're going to look at spheres. So the surface area formula is 4 pi r squared. The volume formula is 4/3 pi r cubed. So the one that you divide by 3 is the one that's cubed. Volume is always units cubed. So your radius is cubed. Surface area is always units squared, and so your radius is squared. It's kind of how I remember it. However you want to, you do have to learn the formulas. So we're going to look at an example. We want to find the surface area and volume of a sphere of radius 9. So our surface area is 4 pi r squared. And then they tell you that the radius is 9. So you just plug it into your formula. So 9 squared is 81. And then 81 times 4 would give you 324. Pi, and then meters squared. So that would be your surface area. For the volume, your formula would be 4/3 pi r cubed. And so 4/3 pi 9 cubed. So 4/3 pi 9 cubed is 729. And then if you multiply by 4/3, you'll get 972 pi meters cubed. And that would be your volume. So I think if you know your formulas, spheres are the easiest because all you have to do is plug in your radius. If you don't know the formulas, then it makes it a lot more difficult. Okay? Alright, so we've got one last example we're going to look at. It wants us to find the surface area of a sphere whose volume is 288 pi. So we're going to start with our volume formula to find our radius. So they told you your volume equaled 288 pi. So we can cancel the pi's on both sides, and then I can multiply both sides of the equation by 3/4 to make that 4/3 cancel. So if you multiply 288 times 3/4, you're going to get 216 equals r cubed. And then if you take the cube root of that, your r is going to equal 6. So then you're just going to plug that into your surface area formula. So 4 pi r squared. And if you multiply, you're going to get 144 pi centimeters squared. And so that would be your surface area for that sphere. Okay, so that's a lot of review, hopefully review, a lot of information. Your homework tonight is lesson 1, number 12, and then lesson 2, 1 through 30. So you have 31 questions tonight. Normally you won't have more than 30. You're actually going to have less than 30 for the next several, well, in the next several weeks you won't have 30 because we're going to get to omit some. But tonight you do have 31, and it's because I want to make sure that you get practice on all of the questions. And number 12 is the only one that wasn't duplicated in lesson 2. So y'all do those and then make sure we can go over your questions tomorrow.